Okay, now we're ready to introduce the whole idea. So the whole idea is following. We have three main steps. First of all, we compute correlation coefficient for our sample, and then we know the sample size, right? That allows us to compute a new statistic z prime by using this expression. So first we compute z prime, then we compute standard deviation. So this is the expression that we use to compute z prime. After that, we forget for a while about R, we work with z prime. We know z prime is normally distributed, almost. So therefore we can compute confidence interval. You remember, in normal distribution, we know everything about normal distribution. For example, for computing 95% confidence interval, we need to take 1.96 of standard deviations, right? That will give you 95% interval of most expected values. So you can get these two numbers here. And then when you know these two numbers, you can compute the confidence interval for the correlation. Because if you know how to get z prime from R, you can also compute the inverse, how to get R from z prime. So in this case, it's not R, it will be rho, because we compute confidence interval for the correlation of population. And this is just an inverse of this. So that's it. So we have three steps. First, we compute z prime, then we compute the confidence interval for z prime, and then we recompute from this to this. Okay. So let me show you an example. So let's say we have a sample of size 98. So 98 individuals, two variables, and correlation between two variables for our sample is 0.88. We would like to find out how big this correlation can be for the whole population. Well, first of all, we need to compute z prime and standard deviation, right? So z prime, it's a half of natural logarithm of 15.67. Where this 15.67 comes from? You remember it's 1 plus 0.88, 1 minus 0.88, right? So it gives you 188, and here we have 0.12. If you take this ratio, you will get exactly 15.67. Okay. Now we computed that this should be z prime, and this is 1.38. So this is our center. It's a statistic of our sample, right? Now we compute the standard deviation. So you can see that it's simply square root of n minus 3. That's what we have here. And that gives you 28 minus 3 is 25. Square root of 25 is 5. 1 over 5 is 0.2. So now we know these two parameters or two characteristics, two statistics of the distribution. The next step is to compute confidence interval. Let's say we compute 95% confidence interval. Therefore, we will take 196 standard deviations. So we compute the lower boundary, take z prime minus 196s, z prime is 138, 138, 196, 0.2 because standard deviation is 0.2. So this is the lower boundary of z prime for population. Now we compute the upper boundary, similarly but plus, so z prime plus 196 standard deviations, 138, 138 plus 196 times 0.2, right? So that's the upper boundary. So this would be z prime for the population. So if you take correlation coefficient of population, and compute z prime based on this correlation coefficient, the z prime value will be between these two with 95% confidence, right? Now we can put this to this and compute rho for the lower boundary. Then we can put this to this and compute rho for the upper boundary. Let's do that, right? So first we take rho equal to E2 times this one, right? 0.988 minus 1 divided to E2 times 0.988 plus 1. And that gives you 0.76. And that, if you take this value, it will give you 0.94. So we know that the rho for the population lies between 0.76 and 0.94 with 95% confidence. Okay, so this is the statistics of your sample. This is the parameters of your population, interval estimate for the parameters of the population. You can see the procedure is very similar to what we already used for average and for variance, for standard deviation. The only additional trick here is that we make this transformation in order to use one of the known theoretical distributions. Okay. Now I have another app, which is samples-based CI. for correlation, and it does exactly what you have seen just in the previous slide, how to compute confidence interval for sample based on the sample, and then you will see how often the population correlation will lie within this confidence interval. So please watch a short video, introductory video to this app, play with this app, and then come back. We will continue with understanding of the correlation coefficient.